Okay, so now I'm going to go to the experiment, which is called Experiment 2, Defect Detection. And we're going to have to set up our eddy current instrument a little bit differently. So I've written the procedure values for aluminum and for steel in these two columns. And so I'm going to set those up, and then we'll look at the crack-like features to see if we can detect cracks, okay? And again, eddy current is primarily looking at near surface cracks, okay? So we're going to work on the aluminum first, and you can probably see those defects. And those defects are very shallow. They're 8 thousandths, 20 thousandths, and 40 thousandths of an inch. So they're fairly shallow, but one question we might ask is, can we detect those and size them using eddy current? So first thing we're going to do is go to the setup, and I'm going to go to frequency, and it says set it to 200. Okay. There's 200, and then it says set the phase angle to 78. So I'll push the phase angle, and I'm going to go to 78. Oops. Oops. Okay, and then it says set the gain at 65. Horizontal gain. So let me set that to 65. Okay, and then it says set the vertical gain, horizontal gain to 72. Alright, so that's this one. I'm going to set that to 72. Okay, so now this is a little bit different than we did for sorting, since we're going to try to measure changes to the conductivity of the same type of material. Instead of nulling in air, okay, I'm going to null on a part of the material that is not defect free, okay, no defects. So I'm going to put my probe on the aluminum block, defect free, and I'm going to null, which is going to bring the instrumentation signal back to the 0. Okay, if I lift off, I get a change. Remember, we have the motion of the field in a electrical area is going to give me a signal. So if I do this again, I'm going to 0. Okay, now I'm going to move over that slightly, and you can see I got a signal to the 11 o'clock position, and now I've got a signal at this deeper defect, and then the deepest defect gives me another signal. So I'm going to null again, and not in air but just above this material. Okay, now I'm going to hold this so it doesn't move too much. I'm going to go across the defect. There's the 8 mil defect, and as I move across the 20 mil defect, you can see I get a bigger signal and a higher, different angle. And if I go over the 40 mil defect, I get a signal again, and you can see that it's quite large, going straight up. Okay, so that's what we're seeing if we have defects in the aluminum. I'm going to change this vertical gain. I'm going to try to make it like 65, because I think that gives me a little bit more uniform signal. So let me try that now. Okay, so I'm going to null again on the aluminum with no defect area. Okay, now let me see if I can get this what I want. Okay, so again I can clearly see when I go across the defects, I can clearly see there's a defect, there's a defect, there's a defect. Now what happens if I try to see it through on the other side? So as you can see, we've got these defects. They're very shallow. This is probably a 1/4 inch thick material. You think I can find that defect on the other side? So let's null here. Okay, and I'm going to move across this. And you can see I don't really see any defects. Okay, I'm going to do this. Okay, so let me do that again. So this is the shallowest defect. And let me do that again. No, one more time on the part. So I'm going to go across this, and I need to be fairly consistent on how I scan. That's the 20 mil defect, and this is the 40 mil defect. Now the other thing which you'll notice is if I move only in the aluminum, there's no defect. Let me zero, null it. You can see I get a little variation of change, but certainly not anything like that, where that's the defect. So if I scan across if I scan across an airplane engine disc, and I'm scanning on material and all I see is something like that, and then all of a sudden I see that, then I know I just went across a defect. And I can tell approximately how deep it is because we're going to be looking at phase angle this week in the lecture. And phase angle, the deeper it is, the larger phase angle it has. So this is less deep, and this is the least deep. So you can see it has a small phase angle. Okay, now I'm going to go to a different material. We're going to go to steel. All right, and we can use the same probe, but we have to have a different procedure. Okay, so let me change the settings to the procedure. So for steel, we're going to use 400 as our frequency. Okay. Okay, and we're going to use 78 for phase angle, and we're going to use 60 and 60 for the gains. And you might ask, how did I know how to do this? Well, somebody's done this experiment before, and so they set up a procedure that seemed to work pretty well. So somebody's already set up this procedure. I've used it before too, so I know what to do. But when you're first evaluating how to inspect it, that's why people get paid to do the procedure and development of the procedure. Okay, so I'm going to go over here to carbon steel, stainless steel as I recall. And yes, excuse me, that's not, I don't think that's carbon steel. Okay, so again, I've got defects that are 8, 20, and 40 thousandths deep. So I'm going to put the 8 mil defect over here, left side. So the first thing I do is null over the part that has no defect. And you can see that I've got, again, basically the indication is in the middle area. If I go over the 8 mil defect, I get this kind of unique signature. If I go over the 20 mil defect, I get this much larger signature. Okay, and if I get the 40 mil defect, it goes way off to the top of the screen. Okay, so let me try this again. Okay, there's my carbon steel, and I'm going to check it in a minute to make sure it is carbon steel. So this is steel, no defect. I go through across it and I find a defect. Okay, so the first thing I notice is there's a defect. It's fairly small, and if I go to a bigger defect, you can see I get a bigger signal, and if I go to the largest one, I get a bigger signal. Okay, so I can tell the relative relationship of those three defects. So that's important. So we've done that. Hang on, I'm going to do one more thing. We're going to stop recording for just a second.